Okay, I think am I audible, right? Awesome. So, good afternoon, everyone. I think it has been a long afternoon, and I think we are seeing an immense amount of development in observability. I think I'm seeing some like a great work out there, and in general, like in normal, in a lot of businesses, AI agents has already penetrated. I will be taking you on a very different journey now. Let's talk about science. And today I will be speaking about LiteFold. We are building the infrastructure for agentic drug discovery. So just to give you a very rough idea of what drug discovery is, it is the art of science of making medicines that can either inhibit a process or accelerate a process in your body. For example, from insulin to Ozempic or aspirin, like these are very names that you might be you might know, and all of these has taken an immense amount of time and capital in order to actually come to the market. And the bad part is that most of the drugs not really come into the market because it's extremely risky. But let's talk about how, like in the end of the day, who makes these? These are like computational biologists and chemists. All the people combined together, they make, like today's medicine. But the problem is extremely simple here. Like all the computational biologists today, or if you think about any kind of modern drug discovery in any frontier lab, it requires a combination of AI engineers, software engineers, infrastructure engineers, and then chemists, biologists, and all of that. And the problem is that the computational biologists, or normally these guys, they have to spend a lot of time in all these different tools, and they do not really get the time to do the actual discovery. And just to give you an example where you guys might be very much familiar with, we didn't had we didn't have to face to write the code in Turbo C++. I mean, today if I snatch cursor from you guys, I think almost all of us we will get like crippled. And this is exactly where today's computational biologists are. They still live in code bases which are like a decades old or like 3 decades older, or like in terminal, where we are now using like tools like cursors or Lovable. And that is why this is how the whole cycle normally looks like, where a huge amount of time and capital is being spent on drug discovery research because of not proper infrastructure, not proper talent, not proper, like everything is very messy. And that is exactly where LiteFold comes, where if you have an idea of research around drug discovery or in normal scientific discovery, you just put that to LiteFold and then you can directly take into validation as soon as possible. And that's where I'm gonna introduce you to our AI co-scientist named Rosalind. Rosalind is our first AI co-scientist that can independently write its own scientific code, that can simulate protein structure interactions, that can design proteins, that can design enzymes, that can design small molecules, that can validate them, it can do extreme deep research across like 200 million plus data resources, it can find toxicity, and it can do almost anything. You might have seen Manus AI. You might think that this LiteFold or Rosalind is basically Manus AI, but extremely focused for deep research and scientific discovery. And speaking of the infrastructure, we have made our own harness where under the hood, the LLM, we have given Rosalind the access of both like CPU and GPU sandboxes so that it can code. And the best part that, that's kind of surprises me as well, that Rosalind can sort of write its own AI models or machine learning or deep learning models. It can train it by itself, and then, it can do its, set of inferences, which is super fascinating. And on the other hand, we have created a whole lab which I will be showing you around. LiteFold Lab is like a virtual lab where which is comprising of a lot of deep learning models, like state-of-the-art deep learning models out there, along with a lot of other physics engines. What we want is that we do not want researchers to do vibe science. We want researchers to accelerate their scientific research. So which means that these AI agents and human collaboration needs to be very much proper, and the interfaces should be just right. That is where the virtual lab comes, and I will be showing you around. But the best part is that Rosalind have access to this virtual lab so that human and scientists can co-work together on this extremely hard workflows. And just before showing you around LiteFold and in more detail, some of the case studies that we have did over the past few months is that we partnered with a synthetic blood company who is trying to develop a recombinant version of blood, and we helped them to come up with recombinant versions of hemoglobin in just like 2 or 3 months. Same, like we have our own internal case study where we tried to create a small drug, which is MTHSP70. It's a cancer invasion drug, and whatever that took normal scientists like almost like 6 to 8 months, we just did that in 4 days. Same for, people like LiteFold, like, some professor from Stanford tweeted about us, about how their whole 1 year of epilepsy research was actually done in few hours using LiteFold. And also, like, we have now an awesome community of researchers that use almost LiteFold every day on their day-to-day research. So this is our team, and this is my co-founder. My co-founder wasn't able to come, but I think I would be now showing you a quick demo of how our LiteFold looks like. So actually, I would like to show this one first. So you might have heard about Kaggle. In Kaggle, there are like a lot of competitions out there. And we asked Rosalind to do protein function prediction, where you are given a protein and you want to predict the function of the protein. And Rosalind first, downloaded all the data from Kaggle. We actually provided the data set. And then it did write a lot of code. I can show you from example here. 1 second. Yeah. You can see that in the script file, Rosalind can write all of these code. And then Rosalind sort of execute all these code from doing data analysis, then writing its own first machine learning model. It started with XGBoost, then it created some GNN models, then it went from geometric deep learning models, and then it did ensembles, and then finally I told Rosalind to come up with a proper report, and as you can see here, Rosalind came up with a proper report of doing all these analysis. All of these things are done by Rosalind, and then not only that, Rosalind also trained its own deep learning model, which was giving us a very good results, like extremely good baseline results. Speaking of which, this is how our LiteFold lab looks like. That, as I've said, that human and AI collaboration should be very much strict, and at the same time, it is something that both of us can sort of properly explore. So here is these are the very custom deterministic workflows. For example, either if we want to do structure predictions, human can either do that manually, or the AI can also start it by themselves. Same for doing a protein design. These are very simple and intuitive pipeline of which of the areas you want to design and which are the areas which you do not want to. And at the same time, Rosalind can also design by protein by itself. And last but not the least, you can also design the drugs. But that's all, and we are kind of moving forward on creating the infrastructure for the next generation of scientific reasoning. You can also we can hang out in Twitter, because I didn't have the booth today. But yeah, thank you so much, and thank you.